at the keynote session. And it is my immense pleasure to introduce today's keynote speaker, Professor Tova Milo. Tova is a professor in the School of Computer Science at Tel Aviv University, where she serves as the Dean of Faculty of Exact Sciences and is the incumbent chair of Information Management. Tova comes from our very own database community, where she served as the program committee chair and did other leadership roles of many conferences. She has made profound contributions in large-scale data management applications, as well as in database theory. Her work has shaped the foundations of modern data management, spanning web data, XML and semi-structured data, graph data, business processes, data integration, provenance, privacy, and explanations. Tova has received many prestigious awards, including the Weizmann Prize for Exact Sciences, the VLDB Women in Database Research Award, the IEEE TCD Impact Award, and an honorary doctorate from the University of Zurich. She is an ACM Fellow, a member of Academia Europea, and the founder of ExactShe, a mentorship program addressing the underrepresentation of women in exact sciences. She has received many prestigious grants, including an ERC Advanced Grant and an ISF Breakthrough Research Grant. On a personal note, I have been very fortunate to have worked with Tova in one of my very first database papers in pods as a PhD student several years ago. If you work with Tova, you will look forward to the fun research meetings, and then she will send you directions and solutions you have never thought of. To the students in the audience, if you get a chance, talk to Tova. Today, Tova will tell us how decades of advances in data management can help address some of the most pressing challenges posed by modern AI systems. Please join me in giving a warm welcome to Professor Tova Milo.
So thank you, Sudeepa, for this very warm introduction. The time thing doesn't work, so you may want to start it so that I'll end my talk at some point. Otherwise, I'll speak forever. Okay. So thank you, Sudeepa, for the introduction, and thank you, Sudeepa and Karsten, for inviting me, and the same for the rest of the SIGMOD organization. It's a great honor to be here and speak to all of you. I'd like to speak today about this feeling that I think we're all experiencing in the last few years. We've been working for decades on problems related to data management, and we developed tools, a whole bunch of tools for querying information, analyzing it, integrating it, cleaning it, doing lots of wonderful things with it. And over the last few years, it appears that all these problems can be solved by just talking to an LLM. And this is worrying, right? So what I'd like to argue today is that all these ideas that we've been thinking of and inventing are actually still extremely useful and can be used to enhance and make the AI world much better. So I've been fortunate, or perhaps very old, to work through a bunch of waves that the data management community have been gone through, from object-oriented databases, semi-structured data, data integration, XML, workflows, crowdsourcing, data exploration, and most recently XML. And every time a topic comes in, we think this is going to change the world. Sometimes it does, but more often what appears to happen is that things that we've been thinking about in previous topics and throughout the period still survive somehow and help us to understand the new topic. And I think, or at least I believe, that this is the same for machine learning. And there's nothing we can say. Machine learning is everywhere, right? From the way we drive our cars, from the way we invest our money or design new drugs. Every aspect of our lives is controlled by, or at least enhanced by machine learning, and this is definitely true for data management and the new way that we interact with information. For me, an eye-opener was this paper from 2022, which was called "Can Foundation Models Wrangle Your Data?" I don't know if you read it. I heard the talk, I think, by Chris Ray, in VLDB. And this was the first time that I understood that you don't need to train a model. You can just take this very general foundation model and just try the prompt with a few short examples, and it can clean your data, it can integrate your data, it can do lots of things often much better than the state-of-the-art algorithms in the area. And once you see that, that was, I think, the first paper I've seen on that, but since then, I think the whole community has been looking at this approach, and we have been using foundation models to query, instead of query languages, dealing with semi-structured data, data cleaning, and we forgot how to do things, half forgot how to do things without them. And the question is, can we just ask LLMs to do everything? And whether we still need all these old ideas, old concepts, old foundations that we've been developing, or should we look for a new job? And my answer is that perhaps we need them now more than ever. And this is because, you know, foundation models, LLM in general, are wonderful, but we all know that they have some shortcomings. Hallucinations, for instance, you know, this is decreasing. You have less and less and less, but they're still there. We don't exactly understand why we get answers. We have no guarantees on correctness, on completeness, on reproducibility. All the things we have been used to in our community, and that people are relying on when looking at data and using data. And these are very important shortcomings. And the question is, can we help to address these problems using the tools that we know? And the thing is, we cannot just take them the way they are. Often, they need to have a new shape, a new idea, something. But as I'll show and I'll claim, this is the case. Okay? So I'll start by showing two examples from some recent work in my group in the context of exploratory data analysis. I'll try to convince you that there is a fresh new way to look at all the problems in this context, and then I'll try to generalize, okay, go from these two examples to the general AI and data management technology, and I'll end by talking a little bit about the future or agentic AI. So let's start with the examples. So what is exploratory data management? You get a data set and you want to understand what's going in. to understand the data, to understand the patterns and so on. This is not just writing one query, but rather a sequence of queries that will help you understand the setting. And the question that we've been asking ourselves is, can we teach a machine, or can we build an agent that will do that instead of us? Instead of the data scientist sitting and writing queries, can we ask the machine to do that? And the point is, what you would like to have in this kind of agent is having the agent finding things that are interesting in the data, that are diverse in the data, and that are kind of natural for a person to understand when he or she looks at the things. And not very surprisingly, the abstraction that we took for this problem is deep reinforcement learning. And it's a fairly simple idea. What you want is you want to build an agent, okay, that looks at a state. The state is your data set or the result of your previous query. It issues an action. In our setting, this is a query. Then it gets a result. And it gets some score, okay, some a reward if the query that it issued makes sense, is interesting, and so on. And as usual, the goal is to maximize the expected reward. And the important thing here is not the fact that we're using reinforcement learning, but really how you direct the agent, how you make the agent explore the space in a sensible way so that it will find what you're looking for. Okay, so this is the general setting, and in this setting, I'll try to show you how we use two old technologies in this new setting in a very different way than they were originally designed to do things. Okay, so the first thing is query languages from semi-structured data, and the second thing is crowdsourcing. Okay, so let's start with the first. So what are query languages for semi-structured data? So who in the audience have worked on semi-structured data? Who doesn't know what that means? Okay, so there are fairly old people here and a very few young ones. So semi-structured data came from the fact that at some point we realized in the database community that we want to query text. And in order to do that, since we didn't have then LLMs, we took the text and typically embedded the semantic tags in it. So in this example, this is a common example in all the papers on semi-structured data. You have a library that contains books, and you tag the beginning of the library with a tag that says library, and every book with the begin and end book tags, and then you have authors inside and so on. And the way to abstract this information is using a tree, okay, that actually describes this information. So the root is the library, the children are the books, and then the children of the children are the title, the authors, and so on. And in order to query this information, what we used to use are three pattern queries. Okay, so that's an example for a query that finds the publications with two different authors. So as you can see, we're looking for something inside the library. We don't care whether it's a book or whatever. It has two authors, and they're different. They have different names. Okay. So that's the retro, and now let's go back to data exploration. So as I mentioned, the important thing is to make the agent look for the things that you're interested in. So typically what you like to do is to explore your data set in light of some goal. Okay, so for instance here, I'd like to find countries with different viewing habits than the rest of the world, and the data set that I'm given is the Netflix TV shows and movies. Okay, so with this goal in mind, I'd like the agent to go and explore the data, and for instance, tell me that India is a rather interesting country because it is different than the rest of the world in terms of the ratings and the types of shows that that exist in the database. Because, for instance, more than half of the things there have a rating of TV 14, while in the rest of the world it's much less, and 93% of the titles are movies, while in the rest of the world less than half. Okay, so for instance, something like that. So this sounds completely unrelated to semi-structured data, right? But still, let's see how it is. So the point is that you can view an exploration path, okay, as a tree. Okay, what does it mean? Actually, what you will see in the tree are the different paths that we take when we explore the data. Okay, so you start from the Netflix database, and then in order to find the interesting countries, you can group on rating and count the shows for India and the rest of the world, or you can group by type and then again compare the results for India and the rest of the world and so on. So you would like to have exploration paths that look like that in order to find the relevant countries. So in other words, you can express the type of goal that you're looking for by this thing that looks very much like a tree pattern query. Okay, it says I'm looking for patterns, okay, that will be generated by grouping the information according to some criteria with some aggregation function, and will compare the results of a country and the rest of the world. Okay? Once you do that, you can automatically have your agent look for patterns that are sensible in this sense. And if you look at the general architecture of the system, you don't have to understand everything that is going on there, but I think the important thing is that you start from stating, or the user states more or less what they're looking for. Automatically, using LLMs and so on, there is this pattern that is generated, and then it is fed into a reinforcement learning engine. This is the red stuff that you see on the bottom of the page, and this is actually the reward. You use it to build the reward function that kind of guides the agent in exploring the database and eventually generating the result. So what's the point? Okay, the point is that what we did is using ideas from one thing in database management, which is semi-structured data, for completely other context, and in a way what we generated is a formal specification that constrains and guides the AI exploration. Okay, and this is one example, but it will be a recurring thing in the rest of my talk, how to use ideas from data management to do something formal, which allows you to use all the, for instance here, all the query optimization techniques to prune very fast the exploration path, to explain what you're doing, and so on. Okay, so that was the first example. I hope everybody understood. And I want to move to the second example, which is related to crowdsourcing. So again, crowdsourcing was a very hot topic around 2010 to 2020. And who worked here on crowdsourcing? Less people. Okay. And who doesn't know what crowdsourcing is? Very few. Okay, so I think it's middle age, kind of, not too young, not too old. So I'll explain in a few words the idea. The point was that we in the database community realized that people, other than the data that we keep in databases, there's a lot of knowledge in people's minds. And when we want to analyze something, we can ask people, we can ask the crowd and get some answers and do something with them. The point is that not all answers are equal, in the sense that not all people know the answers. Some people may make mistakes, some people are more expert, less expert, some people want to be paid for their answers and some less. So there is this setting where you can ask the crowd, they can answer with different correctness level and with different cross, and you want to optimize somehow the computation. So for instance, here in this example, you want to learn what's the name of the new Delhi airport. You ask many people, and the way you decide is by majority vote, and you learn that Indira Gandhi is the name of the airport. But in general, there were much more complicated and smart algorithms for orchestrating the crowd to answer questions. Okay, so this is crowd. What does it have to do with what we're doing here? So let's go back to our example of data analysis. And today, the way typically you gather information is not by asking the crowd, by interacting with an LLM. But we should realize that LLMs, just like crowd, are sometimes correct and sometimes not. Some of them are more expensive, some of them are less expensive. They have their own expertise, and you need somehow to learn how to work with them. And again, rather than reinventing the wheel, you can go back and use ideas from crowdsourcing for obtaining information in a smart and disciplined way. So for instance, suppose you have a relation where you don't know some of the values for the attributes, or maybe you have missing columns or missing rows. You can go and ask LLMs. You could go for GPT-4, you can go for Claude, or you can use specialized LLM. Each of them will have their properties and their expertise. And again, you can use very similar algorithms that kind of optimize on cost versus accuracy to generate a clean data set. Okay? So what have we done so far? What have I shown you? So I've shown a AI-based system whose engine actually uses ideas from data management, traditional ideas from data management, in a very, very different way. So it's not really using the old solutions, but rather the principles of the solutions to solve the new problem. And this is what I'd like to argue in the rest of the talk, that this is not true only for this very specific example and this very specific system, but rather in general for AI systems. So I'll try to generalize and look at the general toolbox of data management and see what we can do with it. So our old systems, okay, had explicit queries, operators, schemas, workflows. And in the AI systems, all this has changed. Okay, we have natural languages, we have prompts, we have embeddings, we have agents, and it's not a one-to-one mapping, okay? It's very, very different. So at first look, it's hard to see the commonality between these new settings, okay? But the thing is that the problems, the core problems that the AI systems are dealing with are very similar in a sense to the ones that we have been playing with it. They need to retrieve relevant information. They're asked to explain what they're doing. They have to validate the result. They need to do it in an optimized way. They need to orchestrate the different services. All these are problems that were things that we have been dealing with and are now reappearing inside the AI systems. And the toolbox, all the solutions that we have been playing with seem to be very useful. So we'll talk about query languages and constraints and provenance and graph data and optimization and explanation and crowdsourcing. How many people have not worked on at least one of these things? Nobody. Okay, cool. So you all have now a job in the new AI era because all these things are extremely relevant to all the layers, okay, of AI systems. And I think the key point, if you want to take one key point from this talk, is that these tools, we have been used to develop them for people and for people to interact with the data. And now they're not used they will not be used anymore by people, but they will be used by the AI systems that interact with the people, and therefore we need to give them a new flavor, but still, the very same principles are important. okay? So let's start with retrieval. Okay, so I think other than LLMs, the second best invention in this context was RAG, the retrieval augmented generation. I think it was the first systems were something around 2020. And okay, so I'll ask, who doesn't know what RAG is? Don't be scared. Or who knows what RAG is? Okay, so there are some people that don't know whether they know or don't know, and that's fine. So let me go over it extremely, extremely fast, just to make sure that we all understand what we're talking about. So the point is, you have an LLM, and you want it not just to use its general knowledge, but rather also to use information, for instance, in a database system or in a file system or whatever external information that you have. So what you do is here at the lower part, you take your information and you chop it into small pieces. It could be tuples in the database, or it could be parts of your text or video or whatever. And you construct an embedding for each part. And you store in a database the embedding along with the information, okay? And then when a user query or prompt comes, you take the user query, you also embed it, and then you use the similarity search on the vector database to find the chunks that are most similar, you bring them up, you give them to the LLM along with the user query to generate an answer from it, okay? So very simple. Wonderful idea, extremely useful. But it took very little to understand that it doesn't work, okay? Or at least in many cases it doesn't work because embeddings alone are not sufficient, okay? And this is for many reasons which we know already from data management, because in many cases you cannot just answer things by small piece of information. You need to do like multi-hop relation. It's like joins in databases. You need to deal with inconsistent information. Sometimes you have things that are semantically similar and therefore close in the embedding space, but completely irrelevant, and so on. So the people in the AI arena also realized this very fast, and their response to it was rather interesting, fascinating in my view, okay? What they did is actually brought back structure in the sense that they went and built knowledge graphs on top of these RAG systems, okay? They build knowledge graphs with edges, with path reasoning, with structured retrieval, and retrieval became kind of an combined one, okay? You use embeddings, but also you use this graph traversal to find the information. Now, if you look at that, okay, we've seen that before. I mean, this is exactly what we have been doing in semi-structured data, in XML, in graph queries, in semantic web also, and now it reappears in the systems that do RAG and similar things. But again, the key difference is that we build these systems for humans, okay? Humans were writing Sparkle queries or things like that. Now, it's the AI system that is using this thing. But in terms of research, everything that we have been done is relevant here. I mean, you have to think again of how to do query planning on this combined structure, which is inspired by what we in the community have been doing. You need to do constraint-aware retrieval. You need to do provenance. You need to do privacy. All these things that we know how to do. These people, the AI people, are much less expert than us in that, and all these things are extremely important. And the same for system optimization, dealing with updates, which we know how to do and is not dealt at all in this, or at least not to the extent that we have been studying it. And all these are amazing research opportunities for us in the AI arena. So another topic, so I discussed retrieval. I want to talk about something else, which is no less important, which is explanations, okay? So A language model gives you an answer. You asked it to explain. They give you a wonderful, very smooth explanation. But the point is that in data analysis, just a story is not enough. Okay, we want our explanations to really be grounded in the data and to be open for inspection. So just to illustrate the difference between these two things, let's look, suppose we are asking something about the data set of Spotify, and the LLM tells us that new songs are more popular on Spotify, okay? And we want to understand why, okay? How did the system derive this thing? Why does it think that it's correct? So if you will ask a language model, you'll get an explanation that will look like that. New songs are more popular because listeners tend to prefer fresh releases, and recommendation algorithms promote recent content. That's a very sensible explanation, but it has nothing to do with the data actually found in the Spotify dataset. For us, database people, a data-grounded explanation could look like that. I mean, it's less readable, okay, for a naive user than this nice text. But what it says actually, okay, is that if you look at the full data set and how things distribute in terms of popularity between the years, then more or less everything is the same. On the other hand, if you look at things that are popular, only the subset of the data of popular songs, then there is this spike, okay, between 2015 and 2015 and 2021. Okay, so in the data set, we can see that new songs are more popular, and more popular is popularity over 65, and recent has a very clear semantics. Okay, so of course this is not readable for, let's say, normal people, but you can take it and explain it, okay, like I just said, okay, you can write a text that explains this thing, and this is grounded in the data. And these two things, these two kinds of explanations are very common in the sense that there are explanations that come from the general knowledge of the LLM, and there are explanations that come grounded from the data set that you have, and LLMs don't know to distinguish between the two things, okay? And what we have to teach the AI community is really to incorporate this kind of explanations inside the processing. And for us, and I think for everybody that deals with information, what makes an explanation trustworthy is when it is grounded in the data, when it's comparative, when it's evidence-based, and so on. So we would like the systems to be able to do that. And the thing is that this is not relevant only for the results of queries. It is very important also for the neural representations themselves. So if you look at the LLM, okay, or the neural network, you have embeddings, you have different layers of the LLM, and often we have no clue what they're doing. We don't know whether the embedding that we're using is good or bad. Okay, there are various benchmarks, but they don't explain really what's wrong or what is right with the embedding or with the different layers. And my point is that we can use explanations from our arena, okay, that are grounded in the data, also for this neural representation. So for instance, you want to understand whether an embedding is good or bad, okay? You can cluster it, okay? And then you can use data-based representations and explanations for the clusters. For instance, you can say cluster number 1 shows or groups together things that have more tempo values, or cluster number 3, the duration in millisecond is longer than the other songs, and so on. So you can have a representation or an explanation, okay, for each cluster. And then if your analysis needs something that you see that is not represented by the clusters, you know that this embedding will not work for you, okay, that you need to find an embedding that is sensitive to the features that you're looking for. Okay, so this is an example for embedding, but you can do the same for the different layers of the neural network and really understand whether it works for you or not. Okay? And something that goes along with explanations, of course, is validation. Okay, so LLMs generate responses and facts and things in a enormous speed, and it's very difficult to do a posteriori validation just because there are too many of them and it takes time to do the validation. And what I argue is that the validation must come as part of the reasoning process. And again, this is something that we know how to do in data management. Okay, so there are different ways to validate. Here are just two examples. We are used to, for instance, validate things through refinements and counter examples. So for the new songs are more popular on Spotify, we can check whether it's true for every genre, for every country, and so on, and realize that it's not true for classical music, or it's mainly true for a top artist, and so on. So my argument is that classical validation mechanisms should be embedded inside the inference and the AI reasoning and pipeline mechanisms, and not be done posteriori. And that's just one example for one type of verification mechanism. Before I move on, I want to talk about optimization. Okay, so far I discussed really the logical layers of interacting with an AI system, but it's very expensive, as you know, to build a neural network, to train it, to infer, then to use it afterwards. And we have been working in databases for ages on optimization, both in the logical level, like join ordering and things like that, and both in the physical level, in terms of caching and materialization and scheduling and resource allocation. And if you look at the AI systems, okay, they have things that are, in a sense, similar. Okay, you have inference routing, you have KV caching management, you have batching, you have retrieval planning, tool modeling, and routing. And if you look at the papers that these people are writing, and it's really like reinventing many of the ideas that we have been working on in the database systems. And really, if you look at AI systems, they essentially become distributed data systems. And I'm sure we will all learn about it tomorrow or more in the keynote. But the thing is, the abstractions have changed, but the optimization principles are there. And there are many things that we can take from what we have been doing and move it to these systems. The last thing I want to talk about, I hope you're convinced by now, okay? Because otherwise, I've spent tons of time, talking to myself. So the last thing I want to talk about is a little bit about agentic AI. Okay, so the whole world now talks about agents and agent composition, and then the whole thing. And my view of things is a bit different. So far, all the examples that I gave you, or what I argued, is that we as researchers can think of how to take ideas and principles and so on and embed them inside AI systems. But actually, these smart agents that can do everything, why not have them do this automatically? Okay, or can they do this automatically? Can agents really learn all the technology, all the ideas, all the principles that we have been working on in the database community, and really embed them automatically in the systems that are being built. So, for instance, for service selection, can they decide by themselves which tool or which model to use? For tool composition, can they decide by themselves in which order to take these new beautiful ideas that we had and compose them together to get into something better? Can they improve the workflow? Can they do autonomous validation using all these tools? So what is needed in order to get there? Okay, so agents need to have a specification of what the tools are doing. Okay, this could be preferably in a formal, declarative way or in text, but still, we need some way to describe what's the input, what's the output, what the service is doing, and then be able to compose these things and reason about the flow, what happens to the data, what are the properties, and so on. And again, who in the crowd worked on workflows and business processes and all these things? That's exactly that, right? We have been working on all these things, not in exactly this thing, not with a textual text description of the input and the output, but we've been there. We know a lot of things. And my argument is that, come on, don't sit just like that. Go and work on that. I mean, this is exactly what we can contribute to. Okay? With this note, I'd like to conclude. So I hope that I managed to convince you that we can teach the new dog our old tricks. And we really spent decades on learning how to help humans to reason about data. And now we need to teach the AI system to do that. Not to go back, but rather to improve. And maybe I'll just finish with one example, like a practical, real-life example from what is going on in Tel Aviv University. We have been working in the last couple of years on building a virtual tutor for the students, which is like a chatbot that takes the course materials and help the students. They can ask questions on the material, they can get answers, pretty much like what you know from other products, except that it is focused on the material that the slides, the video, the course notes, or whatever of all the courses. And what I found out when we developed this system is that the most pressing problem that need to be addressed in order for people to actually use the system and mostly to have the professors allowing the students to use the systems is really this thing of explanation and validation. Kind of being able to understand what the bot is answering from its general knowledge versus what it answers from the course material, making sure, verifying the answers and so on. And we've heard yesterday in the keynote how much verification is important for mathematical proofs. But really in our arena, verification with respect to data, it's a simpler problem and we know how to manage it, okay? We know how to deal with it, and the tools that we have been using are really useful here. Okay, so that's my take on the problem. And I'd like to finish by thanking all my students and all my collaborators and the grant agencies. And again, Sudeepa and Karsten that invited me to come. And I'll be happy to answer questions if you have some. I've been perfect, 45 minutes on the spot.
We have 19 minutes for questions, which is great. So if you could line up on these three or four or five microphones, and we can try to go round robin. So we have Angela here. So yeah.
Yes, thank you, Tova, for the wonderful talk. I liked your perspective of looking at what data management has done and, how to consider the input from agentic AI in all our problems. I want also to mention something, and this goes to my question, the role of humans there. Because in many cases, right, we can consider crowdsourcing or even data exploration, right? Humans are behind it, yeah? You have a set of queries, and these queries will probably have to be formulated by humans. And even though we use LLMs, then we need somehow humans there. And I want also to mention that, since a few years, SIGMOD was actually pioneering a new research primary area, which is called human-centric data management. It includes all topics that you have discussed, yeah, data exploration and crowdsourcing and so on. So what is the role of humans there?
So I can tell you what the role currently is. I cannot predict what it will be in 10 years. Okay, so today, and we've seen that also in the keynote yesterday, human play role in directing the systems towards the right way and kind of controlling, sometimes more, sometimes less, but there is a lot of human input and ideas that come in. I don't know if that will stay. Some people say that AI will take the world, will do everything, and we will go to the beach and have to do nothing, just will have fun. But I think even then, okay, eventually the outputs of the AI systems or machine will be presented to people. And people, as we're curious. We want to understand why we got this answer, what would have happened if we would do something else, is it reliable, and so on. And yes, it's true, the system can tell us, yes, trust me, I'm fine. I don't trust anyone, okay? And I don't think that I will trust completely systems, and therefore I think what I've mentioned about the structure, the correctness guarantees, the validation, all these things I think will stay. Okay, we will still need all these components, okay, whether they're inside or outside or whatever, but we will need them. So I think this is not dispensable and will not be at any point, but that's my take on the question.
Hi, thanks for the amazing talk. I want to ask, how does the data system need to evolve to support the agentic workload in a more optimized manner? Till now, we have optimized data systems for different kind of workloads, but this is a new workload. For example, it will have more concurrent queries. So what are the directions we need to think about?
I think, again, this is, I repeat the smart things that were said yesterday. I think the workloads will be much higher, okay? Because I think humans, when they ask questions, we are limited in some sense, okay? To the speed we think, to the speed we type, to the, whatever we do with the system. And LLMs are, wow. I mean, so I think much heavier workloads is a pressing challenge. So I would say that would be my first priority for work.
Okay, thank you.
Good morning, ma'am. Thank you for this amazing talk. So my question is, I understand that old optimization techniques, if we can integrate it into LLMs, then LLM can work better and can be more powerful. So if today someone want to work in some optimization technique, like any kind of work, optimization technique, so how much important it to keep in mind that this optimization technique, whatever I will come up with, should be easily integrated into LLM, and if I cannot integrate it with LLM easily, then maybe it will not make that much sense or not be acceptable.
That's a tough question and a very interesting one. Okay, do we think that everything is LLM-based or will be LLM-based. I don't know the answer for that, okay? I think that if you can find an application where LLMs don't yet, conquer, and then you can work on things that are not related to that. I would bet that 5 years from now, they will take over that one also, okay? So depends how long-term your research wants to be, I guess.
Thank you, ma'am.
Thanks, Tova, for the wonderful talk. And you do leave us with some thoughtful, insightful comments. I have a question on the point that you made on validation. So I think you make a compelling statement that the validation is to be integrated, part of inferencing, et cetera. The thing that challenges me is that now the ground truth seems to be very fast. And I mean, there is no ground truth. I don't know how to get to the ground truth. The classical way of getting to ground truth in a deterministic database doesn't seem to exist anymore. So what do we do in the realm of validation, for validation in the realm of LLM, if the ground truth is hard to obtain or doesn't exist anymore? Then how do we validate? Is it always probabilistic reasoning? And then, therefore, are we then moving away from classical way of doing deterministic database results?
Okay. So I would split validation perhaps into two parts, okay? Often today, when you work with an LLM, you work with the LLM and its general knowledge, and you work with a data set that you consider often to be ground truth, okay? Which is complementary, okay? So validation for the part that you consider to be ground truth, like the database that you work with and so on, I'd say this part is relatively, or I expect it to be relatively similar to how we measured validation or how we executed validation before. For what you consider as general knowledge, okay, the data that the LLM was trained on and so on, I agree with you. I mean, this is a very noisy ground truth. And for me, validation would be exposing to the user this noise, okay? Telling the user to what extent the result is consistent with all the data, with part of the data, how much trust you have in what you have, and then probabilistic results are very likely to come in and play a role there. So that would be my distinction between the two things.
Thank you. I had another question, but I guess I'll go back to the line.
Okay.
I don't want to be...
Sure.
Hi, Tova. Okay, I guess this is working now.
Yeah.
Hi, Tova. Thanks a lot for all the insights. I was wondering particularly about the last part where you talked about the future. The idea, if I understood it correctly, is take all the literature we've been kind of producing over the last decades and all the tools that came with that, right? And let the LLM select and compose them to solve data management problems. While this is intriguing, so there are two scenarios, right? One is we are obsolete because the LLM would pick the right tools, and even if you look at yesterday, might even evolve and get better tools based on our literature. Or the second point, it will fail completely because it doesn't understand the effect of what tools are and the effects of data transformations. So let me go to the second route. So where do you, if I believe in this more bright future that we still need to teach the LLMs a bit more what data management tools mean and what they can do, what are the big challenges in this future that you envisioned?
So, it's like teaching the LLM anything, okay, medicine, literature, whatever. There's tons of crap, okay, out there, and there are some interesting things, okay? And at least as first step, I would say I would help the LLM, okay, by choosing, having a community that kind of helps the LLMs by choosing pieces of tools and important aspects of of the community and writing these interfaces or using LLMs to write the interfaces and all. It's a little bit like the open source community. Okay, you can write specification of things that you think may be useful, okay, with you know, conditions, per condition, whatever you can say about these things, and help the LLM learn how to use them. So that would be my first step. Okay, maybe next, the LLMs will be smart enough, you know, it's like an undergrad student that took a data management course and then they can do some stuff by themselves. Maybe eventually will be useless. I have no idea, you know, the best thing that you can predict is the past, okay, so the future is a bit difficult. I don't know, but the first step has to be done, I think. It's important that will be done, at least for us as a community, I think.
Thank you.
Well, thank you for the great talk. I very much appreciate this positive spirit that you gave. I think
someone should, right?
I think that's really the spirit. Yeah, I was wondering about the implications for teaching. So should we kind of continue teaching, let's say, the old tricks to our students, or do we also need to adapt kind of curricular on databases, database systems? So is there something where we now need to take on certain trends, let's say?
I think it's a little bit like when you teach mathematics, okay? You still, even though you have calculators and so on, you still teach students how to multiply numbers, how to add them, how on, and then they can use like automatic whatever things. I think it's the same for every topic, including data management. You need to teach the basics, and then you need to teach the more advanced things. So it's kind of a combination, okay? You cannot let them swim without, you know, a little bit teaching them what water is, okay?
All right, thanks.
Yeah, hi. Thanks for the great talk.
Thank you.
Yeah, I wanted to ask about, like, as you mentioned, like, we are moving towards, like, agentic-based crowdsourcing. So, like, in that, like, as we are also incorporating LLM-generated data into the training data sets, so, like, how do we build trust around it? Because if we do crowdsourcing in humans, like, there is a very much diverse perspective, but LLMs, they seem to be biased on the training data, and, like, if we, like, keep doing that, it will propagate throughout the systems. So how do we build trust around those?
So that's another topic that there has been a lot of work in our community about bias and things like that. And I think one thing is to take all these great ideas and try to see, try to identify cases where the LLM generated data is biased and so on. So I think, again, this is a topic where we have great ideas in the community. We probably cannot just use them as is. They will need to go through some adaptation, but we know how to do that. Okay, so I think we're the best candidates for dealing with this kind of problem.
Yeah. All right, thank you.
Yeah, on the similar lines, I was just wondering, like, hello.
There.
Shivani here. So on the similar lines, I was just wondering, like, what happens, like, if something goes wrong, right? Who is here to blame now? Now, as a human, it's very easy to, okay, go find that person. But now, when we are teaching the agents or the LLMs, now if something is not good or not fair, right? So who do you blame here? The person who taught, or the person who reasoned, or the models? I think something to think about those lines as well.
That's a very, very good question. And again, I will say that we've been working a lot on provenance in this community, and tracking the source of the problem, to my view, is related to that. Okay, it's not like I have an answer, but I think, again, probably you could use some ideas, some things from there to help. But again, that's a wonderful research topic. Someone should take it.
Natasha?
So, thank you, Tova. Wonderful talk. So it took me a while to form this question. Let's see if I did anything good. So there is a perception here that all of a sudden databases are somehow the advisor of the LLMs. And I want to give there's some perception anyway, some people have this perception. So I want to give a different point of view that over the years, the past few years, it seems to me that the database is the place where you go find the truth. And if the database says it is so, with the data that it has, it is so. If the LLM says it is so, we need to make sure it is so. This is a huge power, okay, that the databases have. And the LLMs use the databases through RAG systems to increase their reliability that way. And it seems to me that from when databases exist, one thing that we maybe didn't pay as much attention to is how do we get to the end user? How can we be closer to the human? We used SQL for that. That clearly wasn't the right way. But LLMs were closer to the human on day one because they used natural language. So a lot of people in our community and others are using text to SQL. They're trying to make that happen. And it seems to me that there is a future where it's not human using LLMs that use databases. It's more like human using databases through text to SQL. And then the database uses the LLM for richness of the data, because what restricts us is the closed world assumption from the data we have access to, which is never everything. So how about that?
So that's a good question, whether we're like that or like that. Okay, I'm not particularly sure, but look, to be honest, there are many things that LLMs can do that databases, regardless of the query language, okay, may it SQL, may it be natural language or whatever, cannot do. Okay, the things we've seen yesterday, for instance, no database that I know can do that. So I have respect for LLMs, okay? But what you're saying is correct, okay? When it comes to data, it's true, at least in our perception, that what you find in a database is gold, and the rest is maybe gold, maybe fake gold, you don't know. And I think this is the bridge that needs to be addressed or built or whatever, so that on one hand we will be able to use all the beauty and power of LLMs, and on the other hand we can ground it very strongly in the data. And I don't really care whether it's, we use LLMs that use databases or we use databases that use LLM. It's a matter of integration, but to me it's not a question of architecture, okay? It's really a question of principles. What are the principles that are underlying this hybrid computation? And this is what we need to solve, okay, for the LLMs and for ourselves. What are the principles what is a good explanation, okay? What does it mean to be a good explanation in this setting? Okay, what does it mean to be a good answer? How do you kind of restrict and say, okay, that's my answer, but, okay, I think this is what is lacking, like clear, good foundations, the type that we know how to define. Okay, I hope this answers a little bit.
Great, thank you.
Hi, thanks for the amazing example of, LLMs using EDA or coming up with EDA plans to generate evidences that can be used for grounding responses, and that's amazing. But I assume that it implies that the LLMs would come up with the exploratory plan using their general abilities. So I'm just wondering, where do we draw the line between leveraging LLMs' general intelligence and abilities versus strictly grounded responses?
It's a very good question, for which I don't have an answer. Okay, I think it's always somewhere in between. I mean, think of how we use today, how I prepare this talk. Okay, I'll give you, actually that's a good example, okay? I prepared the talk like everyone else by consulting ChatGPT, and I had an idea on how to organize the talk by layers of architecture and so on. I gave it to the LLM, and to my great surprise, it wasn't flattering at all, and he told me, no, this is not a good way to present the things. You should go by problems, okay, and define the thing. Wow, I mean, and I thought about it, and he was right, okay, and eventually, as you saw, I went and did that. So, but, you know, it's not like the LLM did everything. It's not like I did everything. It was kind of a conversation. I gave the ideas. I got some back. I improved, and so on. I think this is how we work today with LLMs. Now, maybe in 5 years, instead of me standing here, okay, there will be a hologram of me or someone nicer, okay, giving a talk on whatever. I don't know, okay? Right now, this is the state of the art, okay?
We will end with a quick question from Norman.
Thanks a lot. I have a question on the user interface level, right? Some people say the user interface of the future for large language models is a text prompt, right? On the other hand, in the database community, we have query languages, and a good query language has formal semantics. You also showed the output, right, as a text often, and you showed in your example that you want to have some more, let's say, structured results. Can you share your thoughts on the user interface level?
I think users are not a uniform, they don't have a uniform distribution. I mean, there are different types of users. Some of them can work only with text or, you know, today maybe not even that, you know, short movies and TikTok and things like that. And some really need to see, you know, the graph, okay, and they find it much more natural, you know, to see the things in a more what we call scientific or mathematical form. So I think if I had to guess, in the future there will be a variety of interfaces designed for the different users, and you would pick the one that works for you. Okay, that would be my guess. We can meet in 10 years and see whether I was right or not.
Okay. Thank you, everyone.
Thank you very much for listening.
So now it's the felicitation time.
I have to stay here? Okay. Oh, does it fit with my outfit? I'm not sure. Yeah, it's okay. It goes well. We can do that.
Thank you. Enjoy your coffee break.